Hello and welcome again to my Physical Science Online Lab video series. In today's video, I want to do a brief walkthrough of the blender and blow dryer lab experiment. So this is an experiment that has a little bit to do with energy and a little bit to do with heat and temperature, and for good measure it has a little bit to do with electricity, so with voltage and current and resistance. So before we start the experiment, let's list out what kind of equipment we need. First of all, what we're doing in this experiment is heating some water. So the first thing that we're going to need is some nice, clean, clear, fresh, distilled water. So this is distilled water. So be sure that you have a thing of distilled water, and in fact we ended up using that again in the solutions lab, the solubility lab I mean. Second thing you're going to want is some sort of a stopwatch or timer. This is a simple kitchen timer. Basically you start it and it counts down to whatever time you have. It'll beep when it's done, just like any other simple timer. Next, we need to have a thermometer. So this is my thermometer. It measures in degrees Celsius, which is what we need. It also has a Fahrenheit setting, which we don't really care about. And you'll need some sort of container for the water. For the part where you're doing this in the blender, obviously the container is whatever container goes with your blender. For the blow dryer part though, you can use any container you want, maybe like a glass beaker like this one, 1,000 milliliter beaker, or you can use a like a metal bowl or a pot and pan, or maybe you have a ceramic bowl or something that is a little more insulated, as long as you're not going to melt it with the blow dryer. Okay, then of course we're going to need our blender and our blow dryer. I'm going to demo with the blow dryer, which is what I have right here. The blender will work similarly. Basically you run it and then you measure what the temperature of the water is before and after. This blow dryer and the blender, you're going to want in both cases to know what kind of power rating these things have. So this thing is a 2,000 watt blow dryer according to the handle. In fact, I looked it up online and confirmed that it's 2,000 watts. It's also says 125 volts AC. It has an actual power adapter on it. Typical around here is about 120 volts, although depending upon what country you happen to be living in, you will have maybe a different voltage. A lot of European countries are 240 or 250, 230, depends on where in Europe you are. And for what it's worth, the blender that I have at home is like maybe a 500, I guess it's 550 watts. So I have data from that already. So anyway, to begin with, let's go ahead and pour our water into our container. I've poured for myself, oops, a little too much. I just wanted 600 milliliters worth. You're probably not going to be able to see that very well on the camera, but you know, 600 milliliters worth. Now I need to measure the temperature of the water. So let's go ahead and point the camera down here towards our little experimental setup. So the camera is pointing at this thing. Gotta wait for the temperature to reach some sort of equilibrium. I think you can probably see it from the camera. In any case, it's about 21.1 degrees. It's actually colder in the room than in the water, so it's going to drop pretty quickly when I pull it out. But it seems to stabilize. On 1.1. See it dropping again. So we take our blow dryer, and as you know, a blow dryer has usually more than one setting. This one's got two speeds. There's a low speed. There's also high speed. Wow. That's hot. Well, so what you're going to want to do is hold the blow dryer. Don't dip it in the water. You don't want to electrocute yourself. But hold the blow dryer a little bit above the water. You're supposed to run it for 10 seconds, measuring the temperature before and the temperature after. So the temperature before was 21.1 degrees Celsius. So now what we do is we turn the blow dryer on. I'm going to actually have to hold it well above the water because if I hold it down close to the water surface, it tends to blast water out, and I can show that to you. You can kind of see water drops flying out. So I hold it up here to prevent that from happening. And we're going to start the timer as soon as the thing is pointing into the water. Yeah. Okay, so I just did 10 seconds of blow dryer on water. Now I measure the temperature. By the way, a lot of that heat maybe went into heating this glass, so I don't expect it to all be found in here. According to this guy, temperature of the water is about 21.5 degrees. For good measure, it's not a bad idea to do a little bit of mixing of the water to make sure, because otherwise you may just heat the surface of it. You don't just want the surface to be heated, you want the whole thing to be uniformly heated. Don't stir too vigorously though, because you don't want to, you're not going to add any energy to it by stirring, but with the blender you might. So this thing right here is saying 21.5 degrees Celsius. So I'm going to go ahead and write that down so I can remember it later. The other part is to turn up to high speed. And now we want to do for another 30 seconds. So this run will be for 30 seconds. Okay, so now we can repeat and actually go ahead and get this new temperature. Just do a little stirring. Wait for this equilibrium thing to happen. And this guy is now saying 22.9 degrees C. So that's it for the high temperature setting. You're actually going to then repeat for the low temperature setting. So can hold it a little closer. Actually, it's not so much a low temperature setting as a low wind speed setting, but you basically hold it in as close as you can without actually dipping it in the water, and you'll measure the temperature changes under both conditions there. Again, some of this heat is actually heating the glass. It's actually a little bit warm to my touch already, whereas the water here is now 23.3 degrees C. So now what needs to happen is I need to show you how to calculate the energy change. Let me get that board. So let's pull out our little board for calculations, and excuse me, what we have is that the amount of heat that you put into water should be equal to whatever the specific heat is times the mass of the water times the delta T of the water. So for example, I had 10 seconds, I had 21.1 degrees, went to 21.5 degrees. And so the heat added to the water is going to be, for water, the specific heat is about 4,180 joules per kilogram times Kelvin or times degree Celsius, like so. And 600 milliliters of water means that I have a mass of 0.6 kilograms. So the heat added here is going to be 4,180 joules per kilogram degree Celsius times 0.6 kilograms times the difference in temperature is 0.4 degrees. So I should be able to plug all that stuff into a calculator and figure out how much heat has basically been added to the water. And it turns out 0.6 times 4180 times 0.4 gives me 1,003 joules of heat. So about 1,000 joules. Now this blow dryer says that it's a 2,000 watt blow dryer. I ran it for 10 seconds to get that. That means that I ran 10 times 2,000 joules, or 20,000 joules through, and I only got 1,000 joules of heat in water temperature change. Now, as I mentioned, some of that's because I also warmed the sides of this glass container. There's not much I could do about that. And in fact, if you hold your hand kind of off to the side a little bit, you can feel that the air deflecting out is also quite warm. So, you know, it's not going to be a very efficient heating process. This seems to be about 5%. The other thing is that not all of the energy that's running through here necessarily is going just to heating the air. You also have to blow the air, etc. So you can repeat that again for the low setting on the blow dryer. You can also repeat it for the blender. See what kinds of efficiencies you get. They're all going to be pretty low. And I think that's about it for the lab. So thanks for watching, and I hope that you enjoyed this video.